Good afternoon. I'm Arun Serafin, Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. Thank you to all attendees for your support of NDIA and ETI, and thank you for joining us for today's webinar, Addressing Technical Debt in Software-Intensive Systems with Carnegie Mellon University Software Engineering Institute. We're happy to co-host this session with NDIA's Systems Engineering Division. Some administrative remarks before we get started. All attendee lines are muted. Second, if you have a question during the webinar, you can submit your question in the question box in the webinar panel on the right side of your screen. We'll do our best to get through all the questions during Q&A. Third, we're recording today's webinar for members unable to attend and for any member who wishes to review the material at a later date. Within the next few days, we'll also post the slides and the recording to our website and YouTube channel. Now I'd like to introduce our moderators for the session. First, Dr. Suzette Johnson is the Vice Chair of NDIA's Systems Engineering Division. She's also Chair of the Agile Delivery for Agencies, Programs, and Teams, or ADAPT subcommittee within the division. She's joined today by Robin Yeaman, the Vice Chair of the ADAPT subcommittee. I'll turn the session over to them. Suzette?
Thank you so much for that wonderful introduction, and we are so excited to be here representing NDIA Systems Engineering Division and our Agile community, and the opportunity to learn from these amazing speakers today as we talk more about understanding technical debt, what it means to us as a defense community, and the challenges that we're facing. And just thank you for your time, because I know everyone has very busy schedules, and we appreciate you being here and learning and sharing together. So over to Robin, who is going to introduce our guest, and thank you.
So glad to see you guys, and I am really excited. This is a treat for me because I get to introduce two of my colleagues. They're absolutely fantastic. So let me tell you a little bit about them. First, we'll start with Brigid, and Brigid is a senior member of the technical staff in Solutions Division and transforming acquisition practice and policy, which we know is desperately needed. Her main focus is in software modernization, where she influences and reforms software acquisition and sustainment policies for the Department of Defense. She's also an IEEE senior member and on the technical review board of Crosstalk. So awesome. And then I'm going to introduce Dr. Ipek Ozkaya. And Ipek is a principal researcher. She's also a technical director. She's got a lot on her plate. Of the Software Systems Group and at the Engineering Institute. She's very focused on things like architecture, design automation, managing technical debt, which we're going to talk about today, and really building software-reliant, AI-enabled systems. That's quite timely. At the SEI, she's worked several government and industry organizations, including avionics, power, automation, IoT, healthcare, and IT. She's also written a book on managing technical debt. In addition, both her and Brigid have just put out a technical debt study, which I'm going to post in the chat really quick, that you should take a look from the Software Engineering Institute. With that, I really want to just turn this over to Brigid and Ipek and hear about all the great things they have to say.
Oh. Thanks a lot, Suzette and Robin, and thanks a lot, Arun and NDIA, for giving this opportunity to us. So our goal was today to really introduce you all to the NDIA study that we did in 2022. The NDIA called out for a specific study that was focused on technical debt. But as we were planning around, Arun suggested that we really do a background in terms of what we mean by technical debt. Although we've been talking about this for a while now, the term was coined in 1992 by Ward Cunningham. It's always good to level the ground with some basics. So I'll do that introduction, and then I'll turn over to my colleague, Brigid, who's going to go in depth into the study, what we did, and some of our recommendations. And Brigid will control the slides for us. I'm ready to move on. All right, so the background and the technical debt fundamentals, we'll go through the congressional study, as I mentioned, but then what we would like to leave you with is how do you get started in your journey of managing technical debt, especially as AI tools are coming at us every moment with large language models and all those generative AI powered tools. We're seeing ever increasing interest in understanding technical debt better and how these tools and technical debt will work together, which was not the focus of our study, but the work that we're talking about today is very timely. Next slide. So let me give a little background. So we're seeing a shift in the DoD acquisition policy, and I am by no means an acquisition and policy expert. Brigid is the expert there, but one of the things that has happened, especially with the software acquisition pathways, a specific focus on calling out the importance of managing technical debt. So that's an important development as we're seeing in the DoD software management. Next. And in 2022, the National Defense Authorization Act called this study, and the SCI team was called to lead the study because we were recognized in terms of working on this, both from a research perspective, but also working with some of the DoD organizations and industry organizations in understanding their technical debt. We've also developed some practices that are articulated in some of the publicly available work we've done. The timeline of the study was quite quick, from May 1st, 2022 to when we submitted the report in December 2023. And the report is out, which is available on the SCI Digital Library. And this week, a summary of the report came out as a blog post with some of our recommendations, which we have all the links, and you're all recommended to take a look, and we're happy to answer any questions afterwards as well. Next, please. So let's do a little bit quick overview of the fundamentals of technical debt. The good news is all systems have technical debt. And this is a good news and bad news in one way. Technical debt is not bad. Managing technical is bad. And I think this is something that unfortunately gets unnoticed on quite a number of organizations, while the reality we live with as systems evolve and as they, especially DoD scale systems, government scale systems, they will have technical debt. What is really eating our lunch is not managing it and not relating it to the software evolution. Next slide, please. So let's go through a little bit of the essentials of the software development process. And I think this is important to recognize because we are typically very good at understanding the visible aspects, the new features, added functionality. Agile software development has done an incredible job in accelerating our ability to deliver capability. Next, please. But there's the invisible aspects, and as Robin, when she was introducing, emphasized, a significant hat that I wear and the SCI wears, in fact, is a focus on architecture. We've done quite a lot of work in software architecture, have published work and put methods out there. It's incredibly important to understand how these systems are structured and how they behave, and they are related to the ability to deliver functionality and capabilities quickly. Next, please. And then on the invisible side, we have defects and vulnerabilities. We're also not bad in managing defects and vulnerabilities because we know that they eat our lunch. We know that we need to be able to manage with good software engineering practices. The missing quadrant here is next, the technical debt. It's invisible, it's related to structure and behavior. It's not always bad, but unmanaged and not recognized on those architectural decay, refactoring, and how systems evolve really get into that. A good software development lifecycle is one that balances these aspects of the software development artifacts in the right tempo, depending on the goals and objectives of the project. Next, please. And if you look into the releases, what we're seeing that actually gets organizations and systems in trouble is skewing it one way or another. Only doing architectural is equally bad as only doing just capability development. A right balance, and the right balance only emerges based on how you're developing, tracking your data, how your development tempo is, and what your priorities are. And this is why the understanding of technical debt is starting to pick up more in terms of importance, because it balances out the inability to evolve systems as you're developing the capabilities. Next, please. And if we look into the causal chain, this is where the subtleties of understanding technical debt sometimes get in the way. this is an example that is a real example. It's in fact in the public domain, and it really demonstrates some of the intricacies that you need to take into account. So if we look into the problem, it's a crash that has been happening on a particular system on unexpected crashes. So when the team looked into the production, what they saw is there were 28 reports that were related to this particular crash that happened in a short amount of time, and that resulted in multiple patches. If you go through the multiple causal chain, the new crashes were discovered after deployment to the users. There were incomplete testing, unclear what other areas of the system were affected, and whether the build dependencies were actually tested appropriately. So that's a relatively straightforward and valid causal chain. When we look at the code, what the team discovered is this crash was happening due to a very large negative letter spacing, and the system crashed on any time that this particular functionality was called. However, it took about 90 days and multiple reports of this and multiple patches when one of the developers said, you know what, we will keep seeing this, something else is going on and we need to investigate it further. And that only then they would discover that there was an external web client API that was incompatible with the system that was injecting this crash. So this is a very good example because it demonstrates the intricacies of technical debt issues that depend on each other. It demonstrates sometimes it becomes very difficult to identify where they might be introduced, and the interest aspect of it, where you continue to pay the interest as you're not able to understand what your strategy in terms of locating is, this ongoing patches, which does not only not solve the problem, it creates inconsistencies across the potential of the code base. You keep patching and now you have multiple places which may not have been consistently fixed. So this is an I like this example a lot because it shows the relationship between the security, the bugs, and the architecture, as well as the difficulty and the accumulating interest. Next, please. If we look into what we mean to detect technical debt, and this is an area that I get a lot of questions at, because we would like the tools to solve this problem for us easy and quickly, just throw some of the analyzers on it and be done with it. Unfortunately, that's not necessarily the case. However, that doesn't mean that they don't necessarily help. There are at least 4 ways that you could detect technical debt. You could detect it from code, where you're looking into code conformance issues and how they are structurally affecting, similar to the example that I just went through. You can detect technical debt from symptoms, like, for example, in this case, the developer was savvy enough to say, we've already patched this 28 times, something else is going on. And you could look into architectural issues, looking by design reviews and analysis of the design decisions. And you could also detect it from the development and deployment infrastructure, where some of the tool change in your CI/CD might signal some of those issues, but also those code matter as well. The figure here describes that there is the overlap between what is visible and invisible in terms of understanding technical debt. And our philosophy is all code matters. So it's not just the production code, but it's the infrastructure code, the testing code that is in totality needs to be considered when you're thinking about technical debt. And it's mostly invisible in the architectural aspects of it. However, it has impact to the visible aspect. In this case, again, our example is helpful. It demonstrated itself as a crash to the end user, yet you need to look into the internal dependencies and how it manifested itself within the system. Next slide, please. Context matters. It's very important to talk about how you're going to separate what causes technical debt and what the technical debt actually is. And this becomes very important. For example, we hear a lot, well, if I haven't documented my system, that's my technical debt. Absolutely not. Documenting the system is bad. You should document the system. However, that is a cause of technical debt. We are advocating reserving the concept of technical debt to actually making the changes within the system artifacts, that is the code, the implementation models, whatever goes into the production of the system, because we have other mechanisms to deal with some of these other process issues, and diluting the concept results in not being able to utilize fit tools for the purpose. Next slide, please. And there are separate areas where causes might occur. And in fact, this is an area where your people, your processes, your context, and your business become important. Like, for example, let's look into the process one. Having not enough automation, not having the right process, and I gave the insufficient documentation example already, will definitely create where your development teams will not be able to align their requirements, their tasks appropriately with their implementation. However, the strategies you deal with in terms of fixing insufficient documentation, insufficient automation are different than looking into the system and deciding what to rework, what to refactor, what not to rework, and what not to refactor. That's why it's important to separate these. Or another example is you might have a lot of issues with turnover or an inability to hire skilled workers. Again, a significant issue. Workforce development is a huge area on its own. However, workforce development causes technical debt if you're not able to hire the skilled developers or skilled engineers or train them properly. And those techniques are different than dealing with the potential problems that they might be causing as they implement the system. Next slide, please. I'm going to stop here and get off the stage and have my colleague Brigid help you go through the study and how we engage with this study. But you'll see elements of what I described in terms of concepts, both in the study as we talked to several organizations, as well as in some of our recommendations. All right, Brigid, stage is yours.
Thank you, Ipek. All right, so we're going to go through the actual overview of the study that we did for NDAA FY22. And what I'll start with is the definition of technical debt. As you can imagine, we have many different definitions of technical debt. Ipek has explained technical debt and typical causes. I will tell you, in my career, I often see people who think technical debt is the work that you didn't finish the previous sprint or the previous planning interval, and they don't see technical debt as a holistic, larger issue. They just see it as unfinished work. And so within the NDAA, they actually gave us the definition of technical debt that they wanted us to use as we went through the study. And that is an element of design or implementation that is expedient in the short term, but would result in technical contexts that can make a future change costlier or impossible. So if you really think of technical debt as a much larger issue than just the work you didn't finish previously, you really begin to see the things that you really need to manage that maybe your organization or organizations you've worked with haven't managed well in the past. So having set the context, Congress gave us that definition. We looked at, okay, is this definition used similarly elsewhere within DoD? And it is. Ipek mentioned the software acquisition policy, the software acquisition pathway policy, and it is within that. If you are a DoD 5000.87 program, you are required to manage technical debt. So that's great. We have the same definition, which is good. And then the DoD in the last year published a software engineering for continuous delivery of warfighting capability, what's called the SWE guide. They published that and they use the same definition. So that's good, right? We're getting the same definition used in many areas of DoD from what we found so far. So having kind of set the context of what it is we were considering in terms of technical debt, we had actually 10 study elements that Congress gave us in that NDAA that they asked, hey, I need you to address these 10 things. And so those things covered measures, data access, forms of technical debt, what the current DoD practices are, what the roles and responsibilities are for people who are dealing with technical debt. They asked us to give them scenarios, decision support aids, and then recommendations on management practices. And so keeping those 10 things in mind, we used that throughout the study. So here's what we did. The study methodology is we started out with a literature review. Let's see what the community is doing, but specifically focusing on gaps between automation and their ability to alert users to symptoms of technical debt, looking at recognized practices for managing technical debt. And then we moved on to, Carnegie Mellon Software Engineering Institute had done a report for an existing customer that was fairly comprehensive. So we went through that and said, okay, what things that we've already done for a customer can we use? And we actually included that almost completely as an appendix in that report. So you can see how we applied, our methodology to a program. And then, of course, we have a number of programs that we support from the SEI, and we use data from customers that we currently support to look at how they are, we looked at their artifacts, their data, their decision-making to bring that in. And then lastly, we did interviews. So we had 16 programs that we interviewed. And again, back to those 10 study elements that Congress asked us to use, we use those as a basis for the interviews. So here's the programs that we actually, and you'll see there's no names, but categories of programs. We had 6 business systems. And these, by the way, are a mix of DoD. We have an agency, which is NASA. And then we have industry that we interviewed out of those 16. And of those 6 were business systems, 7 embedded weapon systems, and then 3 that were command and control systems. And then if you look to the right, as we went through, we assessed where are they in their managing technical debt journey. And the good news is 8 of them actually are actively managing technical debt. I will tell you, I worked in DoD for 20 years and I've worked in and around DoD for 28. And I was a little surprised in a good way, right? That we had half of the programs that we talked to, just 16, but of those half are actively managing technical debt. That's good news. The rest of those are either in the process of establishing practices or understand that technical debt is something that they should be managing, but just are not at a point where they have started that active management. So what did we find in terms of the study? And again, if you go to the link that Robin dropped earlier in the chat, that gives you the blog. But at the bottom is the entire report. If you'd like to go look at it, there's a lot more details if you're interested in more of this. So our first finding was DoD programs are aware of technical debt as a concept and the presence in their systems. Like I said, we were very pleasantly surprised how many of the programs we talked to were actively managing. And we found that DoD programs do not consistently manage technical debt. They don't have consistent practices. And after looking at the literature, the DoD documents and guidance, we understand why. There's some that are very new that haven't yet been managed. So they're managing it, but not necessarily consistently. Technical debt management is often deprioritized. I'm sure many of you, whether industry or DoD, have worked with users who want the new and shiny capability and not necessarily the things that have to be done under the hood. The architectural changes are things that they may not see immediately as value. Sometimes those things get kind of pushed behind because it's not something that the users want quickly. And so technical debt management is often deprioritized. Use of metrics and reporting can help demonstrate that a program is taking technical debt seriously. So we saw quite a few that had metrics that they look at regularly with the teams and leadership and users that show that, which was great. Use of tools can prevent unintentional quality issues from turning into technical debt. Categories of funding can hamper appropriate management of technical debt. If you've worked in and around DoD, you understand colors of money, and we found a number of programs that we talked about how different colors of money complicated the way that they approach technical debt. Again, plenty of details in the report that can kind of help you understand where we were going with that. Mention the software acquisition pathway policy. It actually does require that those programs actively manage their technical debt, which is good. So there are 65-ish programs in DoD on that pathway. So we know we've got a good chunk that are starting down that path, if not already there. The emergence of AI augmented software development tools and their relationship to technical debt is still not fully understood. So that's something we know we have to continue to watch. Industry has established best practices and understanding and managing technical debt, which can inspire the DoD. And we did. We took quite a few things that we learned from industry that we helped put into some of the recommendations. And then educating stakeholders is key. And we actually have a recommendation you'll see in a moment about training. So I'll move on from there. Oh, sorry, forgot the 11th one. Analyzing data collected by tools allows for identifying technical debt correctly, right? So you want to make sure you understand what the tools are telling you so that you can manage properly. All right, on to the recommendations. So we have best practices. So what we found is there are some really good best practices of the programs that we interviewed, and some of the others that we had that we've worked with in-house have some really good best practices. And we recommend that DoD actually share that across the, across the DoD of these are some things that Program X did that was really successful in the way that they managed their technical debt. Maybe it was in the way that they actually took some of their capacity, for agile programs, taking some of your capacity and reserving it for technical debt. We knew one program that did that, and we said, that's a really good idea. That way you can't have that kind of deprioritized. So we want to encourage the DoD to do more of that best practice sharing. Policy and guidance updates. So interestingly, Ipek said we started in May of 2023, we finished in December. There were a number of policy and guidance updates that happened within a couple of months right before we published the report. So it was really good that we had not yet published it. We were starting to see some policy and guidance coming out. We want to encourage more of that. There are a number of things that they have published that will be helpful, but programs have not yet begun to use those things. I mentioned training. We want to make sure we get the appropriate training, not just for the developers, but for the management, the leadership, the users. Everyone needs to understand technical debt, or you do start to get in those situations where it becomes deprioritized because they don't understand the impact and the risk of not taking technical debt seriously and managing it appropriately. Requiring continuous collection of technical debt related metrics. I will say this is collection, not reporting. We did have a few ask us before, wait, what do you want us to report? We said, no, we want you to continuously collect and use. We're not saying it has to be reported necessarily. Financial management regulation updates. I mentioned earlier, colors of money that become complicated for programs who are trying to address technical debt. So we've actually given some specific language we recommend be updated in the FMR. And then making sure that programs have the kinds of tools that they need to properly manage technical debt, whether that's development tools, analysis tools, your CI/CD tools, and the practices that go with it. Lastly, OSD should invest in or utilize technical debt research areas. This is an area that we know that DoD does not necessarily put a lot of emphasis in. And so that's a recommendation that we've made. And we've already talked to some of the folks in OSD R&E who I know are starting to begin to do some of those things. So those are our recommendations. I mentioned a moment ago that, within just a few months of us actually publishing the report to Congress, that the DoD came out with a number of policy and guidance updates. You'll see April, May, September of 2023. So there's the risk, issue, and opportunity, the RIO guide that's been published, the DITRM, the systems engineering plan, and then the SWE guide that I mentioned. So these are things that programs have, policy and guidance from DoD today that they can begin to start using. All right, so getting started. So here are some best practices that we talked about. Ipek, did you want to go through those? Or you want me to continue on?
I'm happy to, whichever. So let me
I'll turn it over to you.
All right. So importance of understanding how to start into best practices is to know where you are. And typically organizations are somewhere in between stages 1 and 2, Although we've seen when we looked into the organizations that Brigid mentioned, those that were more closer to establishing tooling and measurement environments. So start by bringing visibility to your existing technical debt. This doesn't mean that you will throw a tool in your software system and consider that every conformance problem it comes up with as technical debt. It's empowering your developers to talk about it. It's including in your architecture review practices. It's also utilizing tools, but then there's more work to be done after your tools come up with potential issues. Ideally, you're already using these tools to understand your vulnerabilities or code conformance issues. So that's stage number one. And we have these in more detail in our report. And then once you have the visibility, you need to establish goals. First of all, zero technical debt is not possible, as well as that's never the goal. The goal is manage technical debt. Ideally, if you're really developing your system well and with good practices, you're at a manageable tempo. And the reason it's very difficult to achieve zero technical debt is because these systems are large systems, they're evolving systems, technology changes. They're like human beings, our bodies age, systems age. So that creates an inertia in terms of the goals. Which goals means, what are your priorities? What are the areas of the system that you have to focus more specifically on? Are there areas that are hindering further development? And what are the goals? Other aspect of the goal is, once you have the visibility into your existing technical debt, you can have data. For example, we worked with organizations where all of their technical debt was on their database systems. That really says different strategies and techniques versus where technical debt accumulates because systems are very complex. They evolved across many teams, and there are maintainability issues. Those are different strategies in terms of how you're looking into prioritizing them. That's what we mean by establishing goals. And once you have the goals, only then, in fact, you can start thinking about what are the right tools for your environment. For example, again, if you have highly complex systems that require decoupling and re-architecting, that's a different set of analysis tools versus if you have entangled data issues that are within your system. So that's really where you need to understand what are your best tools and measurement environments in terms of looking into technical debt. A question that we get asked about a lot is the metrics question. So it's important to separate the system metrics from process metrics. A lot of the process metrics that we already applied, defect resolution, sprint tempo, any of the agile metrics, are in fact applicable to technical debt. As soon as you start tracking them specifically with labels, then you can use a lot of those process performance measurement environments as part of your technical debt measurement as well. And what will come out of that is, earlier on in this presentation, I showed the black square. How much of that black square you need to include in your release or sprint analysis. Ideally, what we see is about 10 to 15% of each significant iteration, sprint, whatever your tempo is or measurement unit for releases is, should be spent on activities such as managing technical debt. This doesn't mean that you're always playing catch up. This means you're intentionally focusing on high priority issues. Next. Brigid, can you advance the slide? Oh, all right. So here's an example. This comes from some work that we've done with several organizations, and we aggregated the data to make sure that we don't expose some of the details. Once you've started collecting data, then you are able to look into it in more detail. I'll focus more on the figure. Like, for example, in some of the examples we looked at, when we look at the code structure, there are certain areas of types of issues that were happening. Like, for example, UI design, if there are accumulating issues and rework required in UI design, that's a different team versus if you have dead code. You might say, you know what, I don't care, I have dead code, I'm going to deprioritize this because I need to put my effort into something else. It could even be capable to development. So the incentivization of the developers and acquisition organizations to disclose technical debt results in this kind of data so that you can look into who are my experts that is going to resolve this, how do I prioritize it, becomes important. And there are some tools in fact, that include technical debt as an issue type in some of the issue management and systems, or a lot of these systems already come up with customizable templates and do include technical debt as a label. In fact, one of our findings, as Brigid mentioned, was we were very pleasantly surprised with some of the organizations. Some of them use enabler stories as a way to link to technical debt. Others, in fact, use technical debt as technical debt stories, and those were the organizations that were, in fact, better off. And a lot of the existing practices, and this is the good news part, you don't have to reinvent new practices. A lot of the existing practices already apply out of the gate. You just intentionally need to include, all right, let's talk about our technical debt, which means what are some of the areas that we need to focus more on that might be accumulating rework? What are some of the areas that are, in fact, accumulating more issues because we keep building on top of them? And that's also important to recognize. The reason technical debt becomes an issue is early on, it's maybe a naive and innocent shortcut that you take. But as you develop more and more capabilities onto that software, it becomes more difficult to untangle. It becomes harder to understand where might be some of the changes that are required. And it might, in fact, to some extent, become impossible to redo and rework because of all the complexity and new software that is built on top of that. So the practices are with an intention to be able to manage some of those and the prioritization. Next slide, please. So we talk a lot about the technical debt timeline. There is the unintentional and not well managed timeline, which is there's the occurrence of technical debt, which you may be or not be intentional. There's the awareness of technical debt, which typically the reason we see all the problems is awareness comes significantly after than the time it was taken on. And then there's a tipping point, it keeps accumulating. And because you haven't addressed anything, it starts now really eating into your resources. And even if you remediate, it might be too late. So there's that sweet spot, you miss it. All the practices and intentionality we're trying to bring into it is to change this timeline into a more manageable one. Next, please. Where ideally the awareness and occurrence of technical debt are at the same time, or as close as possible, and it's intentional. You are taking on technical debt because maybe you're locked into a particular hardware, software, you're not able to rework it. You're taking it on because you know that you're going to retire a particular part of the system and you decide to carry it. Or you're taking it on because it's going to provide more information for you. You're maybe experimenting with a part of your system, and then you're going to change it as you learn more of that. And remediation is also then timely. You decide on the metric or how you're going to decide when to remediate and what resources you're going to put it. And then you never reach the tipping point, and then it becomes an asset. So technical debt from that perspective is a design strategy. It's a system development strategy as long as it's managed. Otherwise, it becomes a dear colleague of ours, Cliff Curtin, calls it death by 1,000 cuts. You don't know where it hits you, and it becomes distributed all across the system and becomes very hard to put your hands around. And I think with that, this might be our last slide. Yes, thank you. And we're, I think, ready for questions.
Awesome. So that was a great presentation. And I see that we probably already have some questions in the chat, and feel free to ask more. So the first one is, oh, you've already got that. What kind of rules? Did you see, team, what kind of rules that requirements in architecture play in managing technical debt?
So I am not sure what is meant by the rules, but I think to the extent that I interpret the question, let me try to answer it, and please ask further questions if the answer does not satisfy. So there is definitely a relationship between how the requirements are implemented in the system and the architecture. Technical debt is about rework, refactoring, or redoing, which is the accumulation of interest, if you will, from the perspective of the analogy with the financial metaphor. So if you are, for example, not implementing to the requirements correctly, you might incur technical debt. Or if your requirements change on you, you might incur technical debt. So those might be some of the categories of, I don't know, areas that you look. I don't know if that's what you mean by rules, but that's one way to look into how they relate to each other and how they relate to managing technical debt.
Fantastic. The next one's from Wilson Miles, and he said, what are the recommendations or recommended forums and challenges for sharing best practices across the DoD?
I'll take that one. So we participate in a lot of different forums, and I'm sure lots of you on the line do as well. There are a number of software modernization forums. DoD CIO has a community of practice. There are a number of other community of practices across. There are things like the weapons systems software forums, right? There are lots of those different community forums, and we don't need a separate one for technical debt. We need to be talking about technical debt in the forums that exist, right? We need to bring that to light and make sure that is a topic that we always discuss. Ipek and I did last fall brief this to the DoD CIO community of practice, and we got lots of energy and engagement around it. And I think we'll continue to see that as we continue to make sure it gets brought up. Ipek, did you want to add anything there?
I think it's very important. The last point you brought up is very important, Brigid, because technical debt is very much related to every single practice that we utilize and already apply within the software development lifecycle. It's not necessarily lapping on it. However, similar to how we're doing requirements, architecture, testing, implementation, CI/CD, it is a fundamental practice area within the software development lifecycle. So it needs to be integrated with how we're talking to these. That's why we were incredibly excited when technical debt, even if it appears as a sentence, it appears in the software acquisition pathways, and that creates a wonderful hook to be able to go in more depth and explain the practice, similar to its relationship to architecture and rework becomes important. So all of those forums are opportunities in terms of including that. I think the mistake happened is everybody initially, when the idea started taking root, was looking for the magic tool where you press the button and it's going to give you a number. Here is your number of issues. Here's how much it's going to cost. And here's how to resolve them. How we all wish software development and continuous evolution of software systems were that simple. I think now we've finally moved away from that perspective. See quite a number of questions coming in.
Yes, they're going nuts here. The next one is from an anonymous attendee. How can industry help shape the requirements that are surrounding technical debt? Is there anybody leading the charge in this area?
I can take that, and everybody please chime in, as you know, because I know all of you come from industry as well, all the three of my colleagues here. So some of the industry, in fact, is not even shy about talking about it. One that I'm very familiar with is, in fact, Google. They published some of their approaches. And Google is a very metrics-oriented organization, and they've looked into whether there is a golden set of metrics that might help managing technical debt, and their findings are consistent with our observations and findings. It's really team-specific. It's specific to the context that you have. However, even in the qualitative sense, understanding whether teams are dealing with some of those issues helpful, and we reference some of that work already in our reports. There are other industry that I cannot name here in the publicly. However, they are prioritizing managing technical debt, in fact, as one of their differentiators from rest of their competitors, because they realize that as they manage technical debt, they'll be able to get ahead of it and utilize it as an accelerator rather than as something that's going to reduce their resources or efficiency in terms of cost benefits of the development.
That leads right into the next one, which is what are good approaches, and I know you know this, for evaluating the cost of technical debt and maybe the cost to remediate that debt?
So we talked about the practices. If you're not recording it, there's no way you can talk about the cost of it, right? So you have to start by making it visible and looking into the scope of that particular technical debt and aggregating from it. So once you have that data, understanding the cost of technical debt and cost of remediation is no different than how you're looking into cost of remediating your vulnerabilities, your bugs, your new capability development. It's really based on that input data. And I think that's what has puzzled our industry. Because that input data did not exist, we were thinking, okay, how am I going to cost this? As we develop that competency by bringing visibility, and through bringing visibility by sizing it correctly, we're able to provide the cost and benefit and remediation. Like, for example, if the technical debt item that you're putting in is like rewrite my software, obviously you won't be able to cost it appropriately at that level of high level. However, if you're able to get into the more lower levels of granularity with the example table that we showed, then you can start talking about, all right, now I can put my hands around it and use my existing techniques to help the cost of remediation assessment.
I love that. The visibility, I 100% agree. The next one, and
Robin,
let me,
can I add to that real quick?
yes.
Sorry.
No, do.
I wanted to kind of address the last two questions, right? So kind of from the defense industrial base perspective, working with DoD, I would encourage the industry partners to make sure the government understands the importance of technical debt and the cost of delay in addressing technical debt, right? I think sometimes industry will say, hey, we really need to make this architectural change, and we understand that it's going to slow us down and it's going to cost X. And the government goes, yeah, I don't have time or the money for that. And often the government will move on because there's too many priorities, but they don't understand the real risk and cost of delay that's involved in what is compounding over time, right? If we kind of go to the interest that's compounding on that technical debt, I think that often that conversation doesn't always happen. And I think that's where industry can help the government. It's making sure they fully understand those pieces.
That's excellent feedback, Brigid. The next one, both of you, is it best for the government or the industry performer to be tracking technical debt? Should it be worked in the contract terms or incentives?
Brigid, do you want to get us started on this one?
Sure, I will. Yeah, so I think it's both, right? I think the industry partners should be doing it in conjunction with the government. I'm very much a fan of industry and government being collaborative partners in this and making sure that they both understand. And, they both understand, the government's looking at the metrics, the industry partners looking at the same metrics, or we understand where we're going. Again, like I said, we understand the cost and the risk of not addressing it. But I think too, that's a good point. I think having it in the terms and incentive, especially if they're a software pathway program, that's a requirement, right? It should be in the terms and incentives, but it's a good practice for any industry partner to have that in the incentives. If we can find a way to, remediate some of that technical debt in a way that gets us there quicker and we've saved money, then there should, be consideration for an incentive there. So yes, I think absolutely. Go ahead, Ipek.
And it's also important to recognize this is a collaborative effort. It's not technical that should never be used as a way to gut you either way. Like, okay, I'm going to not disclose my technical debt, hence I'm going to make money out of it from a contractor perspective, or from a government perspective, I'm going to withhold money. Because as we're saying, some of this technical debt might be decided to stay on. And if that's visible and collaboratively decided, that's the ideal place you want to be. It could be because you're working with a legacy system and some of the tools and techniques or the hardware may be locked in and you may not be able to change it. You want to be able to disclose that, look into its risk exposure, and carry that on intentionally and with knowledge, rather than just burying it under the rugs. But we're already seeing contracts where the government organization is asking, how are you managing your technical debt? We would like to see your software development plan, which is common practice, which includes technical debt management. So I think once we see more of these examples, the fear around it will, if you will, reduce as well. And I don't know whether it's fair to say fear, but maybe timidness or not knowing how to manage from a contracting perspective will be less scary.
Absolutely. So the next one's near and dear to my heart because I've seen this a million times. I bet you guys have too. It's from an anonymous attendee. Said, I manage research and development. I find that some prototype projects are transitioned and accepted as if they were a complete project. You know, how can we manage research code to be moved to production code? And he discusses how hard it is to get money to fix it after the fact. Once it gets into operations and kind of the development of like a Frankenstein solution. I've seen this happen many times, so I'd be interested to hear you guys answer on this.
Well, this is the, go ahead, start. You know it, go ahead.
I was going to say, so we mentioned earlier about the financial management regulation, right? The FMR. We've got to get changes to the issues that we have with colors of money. I think we all know software is never done. There's, in my opinion, software sustainment is a myth. It's not a thing, right? If you are sustaining and bug fixing, there's no way you're not actually developing new code. You're actually developing. You're always developing. There shouldn't be phases like this in terms of the way that we in the DoD say this color of money can only be used for this, and this one for this, and this one for that, right? That is putting up stovepipes and walls between good software development and modernization of software over time. And so we've got to fix that piece. And then to me, that helps to fix some of what this anonymous attendee is asking for, because once you're paid for that software, it shouldn't matter what color of money you have. Yeah, we're never going to deliver perfect production ready code. There's always going to be something that needs to be done, but that's a key piece. Over to you, Ipek.
So I think one of the other important things to recognize here is research code hopefully does not mean crappy code or haphazardly done code. I think that's maybe a place to start, because I've seen it happen in many times where research code has been, and sometimes with good reason, because you don't know the technology and you're trying to learn through it. So there's maybe some competency to develop from the research code perspective on one hand. On the other hand, tracking might help. If you start making those, for example, we made this decision because we want to be able to demonstrate particular capability fast, because we're looking into exploring some of the boundaries of this particular capability. However, we are aware that this will need to be redone, and putting that as early as possible in front of the decision makers is one strategy. I'm not suggesting that this is going to solve the problem, because we've all seen prototype to product problems over and over again. However, bringing some data into it might help. And I think the colors of money is, in fact, we've seen over and over again. And thanks for remembering that, Brigid, as a critical aspect of this. It's not only prototype to product or research to product, it also happens between development and O&M, right? Sometimes the technical debt issues are, okay, it's not my problem. O&M funds will be used, O&M teams, or that's maintenance and operations parts will look into it. That also creates similar problems. Bringing some of the data is one starting point for this.
All right, I think we have time for maybe one more. We've got a lot of different questions out here. Let's see. Oh, it's just there. Well, the one I'll go to is, how should technical debt affect hardware design and the development in software embedded systems? Is there a difference?
So I'll take it with my software hat on, and then Brigid, if you have anything to add, please do so. One of the things we're trying very hard to say is, like, when we're talking about technical debt, we're talking about a software system perspective. There's absolutely a parallel to be built within the hardware, where you may be doing some of the design decisions, hardware design decisions, which might bite you in the long run. That there is an applicability there for sure. However, it's important to make sure that if that is being used for hardware development lifecycle, separate how it influences software versus just the hardware development, because hardware is not as easy to change. Some of that rework is a whole different kind of implications from the supply chain management and whatnot perspective. I don't pretend to understand that aspect from hardware. However, from the perspective of hardware software coevolution, you could definitely apply the concepts and the practices as we're talking about it, because the rework consequences would be similar. How it influences software or how knowing software influences hardware design, those are similar. And in terms of tracking the consequences are definitely similar.
Yeah, you're
Brigid, I don't
spot
know
on,
if you have
Ipek.
anything.
And I'll add, you know, often what I have seen is you have hardware obsolescence issues that ends up driving technical debt in software, because you can't just necessarily do a lift and shift. You might have an operating system change, a data interface change, right? And so sometimes you have it going that way and sometimes the other way. Maybe you have a target compiler because you have a unique processor that is no longer supported, and you are at the same time have some kind of modernization in hardware that's making changes there, right? So they're kind of very much going back and forth between the things that are driving each other on the hardware and software side that will also create technical debt between them, just in the way that they are so tightly coupled and integrated. So that's it on that one.
Awesome. So lots of great questions, but we're going to have to come back to our sponsor, Hearn. Maybe we can get these ladies to answer some of these questions offline and we could post them, you know, on NDIA, because we have so many great questions. And I just want to thank you both. You did amazing and I really appreciate it. Over to you, Hearn.
Yeah, and maybe I was going to ask that question, Robin. I'm assuming we'll be able to save these questions and we'll see if we can summarize them and send it a blog post or something like that. And that could be accessible to the attendees as well as others.
Great idea. Thank you for offering that, because I know I can definitely capture them. So yes, that would be fantastic.
Well, that's great. Thanks, Robin. Thanks, Brigid and Ipek and Suzette for joining us on this webinar and that great presentation. Thanks also to all of our attendees and for all of those great questions that overwhelm the system, but we will do our best to work through the backlog of questions in the spirit of this whole presentation and catch up before it's a net negative to us. We're going to post the recording and the slides online as soon as possible. If you have feedback about this event or ideas on future events, especially topics you'd like to see us cover in the future, please email us at eti@ndia.org. We'd especially like to hear from the divisions, people in divisions. These kinds of joint events with divisions are exactly what ETI wants to be doing more of. I want to take this opportunity to highlight a few upcoming events. First, the second NDIA Emerging Technologies Conference is going to be held August 7th through 9th at the Washington, D.C. Convention Center. Confirmed speakers so far are Undersecretary Hsu and LaPlante. Last year's event sold out, registrations, exhibits, and sponsorships, so please don't be late. Look out for information on all of these opportunities, plus the opportunity to present some of your technical work coming soon. We're hoping that registration and all that information will be available at least by early May. I also want to talk about our Tech 101 series. The next in this series is on GPS. The Tech 101 sessions are intended for a lay audience. It's a 1-hour webinar that gives you an introduction to a technology area and talks about its importance for DoD and defense industry. So Tech 101 on GPS is on April 4th. And then the May Tech 101 is on generative AI. And then I think the June Tech 101 is on trustworthy AI. So please look out for registration information on those. And then the last thing I want to hit is on April 30th, we're hosting a webinar with Undersecretary Shu and the other service S&T executives from Army, Navy, Air Force, and DARPA, where they're going to summarize the fiscal year 25 budget request for science and technology programs in DoD. And that information on that webinar and registering for that webinar will also be available on the NDIA events website. I finally just want to mention our podcast, the Emerging Tech Horizons podcast. Recent episodes have been on National Defense Industrial Strategy, the NDIA, some of our work on supply chains. Upcoming episodes will be on the Planning, Programming, and Budgeting Commission's final report and how it affects emerging technologies, also on topics like cooperation with India. The podcast is released bi-weekly, YouTube, Spotify, Apple Podcasts, wherever you get your podcasts, or you can find them on our YouTube channel. With that, I want to close the session. Once again, thank the division and thank all of our speakers and thank all the participants. Thanks for joining us today.